Hello friends, this is Durga from IT University. As part of Transform Stage Store, currently I am talking about calculate aggregate statistics using Spark in Python context. And we have seen totals, we have seen by key aggregations as well. Uh, Continuing by key aggregations, in this video I will cover how to get the max by key, and also I will cover how you can actually create more complex functions uh, for uh, uh, while processing the data, which means that how we can actually create Python functions and how we can invoke as part of our Pyspark commands or programs. And also I will try to cover uh, how we can write the logic using SQL embedded in Python. So I will be covering three. One is max, other one is using a regular Python function to process to be invoked by the Pyspark programs, and the third, how we can also use SQL to get the aggregations embedded in Spark or Pyspark. So let me go ahead and define the problem statement for the first scenario to get the customer ID with max revenue. So if you look at the orders table and orders items tables in Hive, describe orders. Orders have order ID, order date, order customer ID, and order status. And order items have the order ID, order item ID, and the order item subtotal. So we need to add order item subtotal from order items joining with orders, and we have to get the date as well as the customer ID, and then we have to get the revenue for each uh, date for each customer, and then also I want to see who is the customer with which is generating highest amount of revenue for each day. So from orders we have to get uh, order ID as key and order date as well as order customer ID. From order items, so I have to get order ID, order item quantity, sorry, order item subtotal. To join, I need to get order item order ID. So already I have shown you how to join the data. So these 5 commands I have covered several times in the past. It is passing orders and order items and getting the order ID from the table, and then it is generating the uh, record of that table. So order ID will be the key for orders table and the record will be the value, and order ID will be the key for order items table and record will be the value for the order items table. Using order IDs, which are keys for both the data sets, I am joining by running the join function. Again I typed in the wrong window. I pasted in wrong window. Now I am pasting in the right window. Now if you see the results by querying the RDD, join RDD, take 100, print of 5. Here this is the order ID for the corresponding record. This is the entry from order items table, which include order item ID. The first column is order item ID. This is order ID. This is product ID. This is quantity. This is order item subtotal. And here from orders, this is order ID. The first field is order ID. The second field is order date, and the third field is customer ID for that order. So now if you try to understand, this is a tuple in which order ID is the key for this tuple, and value is another nested tuple, in which it has two attributes. One attribute is from orders and the other attribute is from order items table, and from here we have to parse the required fields, which are order items, subtotal, order date, and customer ID. That can be achieved by using this command. Here the key is order date and the customer ID. So these two are keys, and the way we can read this is in this case, if you define rec as the variable, this is the rec of 0 and this entire stuff is rec of 1. And then to get the order date, you have to read this as rec of 1 of 0 and this is as rec of 1 of 1. And on rec of 1 of 1, which is a string, you have to apply the split function with comma as delimiter, and then subscript 1 will be the order date and subscript 2 will be the customer ID. So these are the these two we are building as a tuple, which will become the key, and then we are actually reading the order item subtotal from rec of 1 of 0 split by comma as delimiter, and then this is 4 in the subscript, because in Python it starts with 0. As it is the fifth element, we have to use it as 4. So this is the command. Paste it and enter. Now you can actually validate. Copy, paste, take 100, print of I, and hit enter. You can see the key is a tuple in this case with the two values. The first one being order date and the second one being customer ID, and the value of the tuple is the revenue. Now for this date, for this customer ID, we have to add all the 4 records. Like that we have to do for each date for each customer, and then we have to get the order date out, and then we have to compute who has the maximum revenue, which we will see. So for this, as the input type and the input type for our aggregate function and the output type for our aggregate function is same, because we are trying to pass input as the float values, which is revenue, as input, and then we are getting sum of the revenue as the output. The data type is same, hence we can use reduce by key directly and paste it. Now you can see for I in, copy, paste, take 100, print of I, and hit enter. Now you can see that there is only one entry for each customer and for each date, and then you can see the sum of the order item sub value as the value. And now what we have to do, we have to get order date out, because and then we have to generate the customer ID and the sum and the revenue for per customer per day as value, so that we can actually compute the maximum revenue customer for each day. So in this case, let me run it again. In this case, this is represented by rec of 0 if the variable name is rec, or lambda parameter name is rec, which is a tuple. Hence, if you want to get the date, this will be rec 00. To get the customer ID, this will be rec 01, and this will be rec 1. It's a simple value, so you can directly use it rec 1 like this. And then in map function, we are getting the date as key, and then customer ID and the revenue as the value. So you can copy paste this one also. And now in this, So far we have seen how to get the sum. Now we have to see how to get the max value. So I have shown you how we can do the max on the reduce function also. Now I will be doing on reduce by key. If the similar logic, in this case, the input parameters are, this one is the accumulator and this one is the value. In this case, value is the tuple. So we have to check the maximum revenue customer by actually comparing the revenue of each of the value. So in this case, as from the value, as the first one is customer ID and the second one is the revenue, we have to compare based on the revenue. And if you want to write if condition in one line like this, in Python you have to use x if or the value which you want to return if the condition is true, else the value which you want to return if the condition is false. In this case, x of 1 is uh, the first values, the accumulators uh, accumulators revenue, and this one is the actual records revenue. If the accumulators revenue is greater than or equal to actual incoming values revenue moving forward, then it will return the accumulators revenue, else it will return the it will assign the values revenue to the accumulator, and then accumulator will have the maximum revenue. Like that we are computing moving forward, and by the time it iterate all the values for each key, it will get the maximum revenue. And in this case, what we are returning, we are actually returning the tuple which is having both customer ID as well as the revenue. And we have to use reduce by key because we are passing the tuple as the input. The tuple have two data types. First one is the integer for customer ID, and second one is revenue. Also, when we actually compute the maximum, we are returning the tuple only. You can see here, even though we are comparing only the revenues, we are returning the entire tuple. So we can use reduce by key here. If the input is different, if the input data types are different from the output data types, then you have to use either aggregate by key or combine by key to implement the similar functionality. And before running this, let's iterate through this map function. It's very important to do this because you can understand what is the data type of this. If you have u before that, it means it is string. If you don't have u before that, it means it's a numeric value if the underlying value is numeric. Print of I and hit enter. Now you can see that this is float because it does not have u before that. So you can directly compare like this. If it has u before it, then you have to convert it into float, and then you have to return. You have to compare. Now I am actually running this logic to get the maximum revenue of the two values and assign it to tuple, and then do it iteratively until all the values are processed. And now you can actually see for I in top customer by revenue, copy, paste, dot sort by key. We have to get 364 records because we have 364 days worth of data, and on each day you have you will be having one customer with the maximum revenue. There can be duplicates, but this logic will only give one customer. It will not give all the customers which have the highest value. If you want to do that, you have to do the self join after getting the maximum revenue for each day. Anyway, sort by key dot collect print of I and hit enter. You can see that on last day for our data set, which is July 24th 2014, and the customer ID 3464 is the one who is generating the highest revenue. And you want to, if you want to get the customer details, and that those details are not available in orders and order items, hence you have to join this customer ID with the customer's data set, and then you can get the customer details as well if you want. But I will not be covering that. It's pretty straightforward. Probably it might be a good exercise to join this dataset with customer's dataset and get the customer's details. And also you can actually run count on this to validate how many it is returning. It is returning 364. And now so far we have seen using the single line functions as part of the as part of our anonymous functions, but at times it might make sense to actually use the regular functions like this, because here if you have more complex logic to compare, writing in single line can be cumbersome. To make it more readable, it might be better to actually uh, uh, to uh, to actually format the code better before executing it. So now I will demonstrate how to use regular functions rather than single line code like this. You have to define the parameters like this, and then you have to pass to the function, and then before executing the function you have to create a function with a def command and give the function name. So here, instead of using anonymous functions, we are actually creating the separate function, and in this we can write the logic. As I have mentioned earlier, Python follows indentation for scoping. It does not follow the curly braces. So for this function, all this code which are indented at the same level will be at one scope. So this if else statement will be assigned to this function. And then in the if condition, I am comparing the same thing. I am reading the second attribute from the tuple, which is our revenue, and comparing which one is max, and then returning the max one. And then it will assign to the accumulator, and the and it will move forward through the values because of this reduce by key being invoking this find max function recursively. And then we have else statement, and under else statement also there is only one statement under the scope, which is return y if the accumulator's revenue is not greater than or equal to incoming values revenue. So I am copy pasting this one, hit enter, and now you can actually run this function and get the print statement to validate the results. You can see that we got the same customer ID with the same revenue what we have seen earlier. Only difference is instead of writing a single line code, I have invoked a function, a regular Python function here. So you can have any Python logic here as long as it satisfies the parameters and the invoking functions specifications. That being said, we have covered all the aggregations using Python as programming language without any SQL so far. We have covered totals, we have covered by key averages, and when we try to do by key averages, we have covered all the functions starting from count by key to group by key and reduce by key, even aggregate by key as well as combine by key. That being said, in this I will also cover how to write SQL. I will take only one example. I will not be trying to write all the examples in SQL, just to have it. So first, to run in the Hive context, you have to import a Hive context like this and hit enter. Now the Hive context have the Hive context is the variable which is holding the Hive context, and then we can issue the SQL statement. In this is the query to get the order date, order customer ID, and the max of to get the order date and the order customer ID who is having the maximum of revenue, who have generated maximum of revenue for the organization. So it's a self join of two nested queries. The first nested query starts from here until here. It's a simple group by order date and order customer ID, and we will get the order revenue generated by each customer for each day. And the second query starts from here and ends here, and it actually uses another nested query to get the sum of order item subtotal for order date and order customer ID. Once we get to the sum, then I am using order date. I am getting order date and maximum of the sum. So for each order date, I will get the maximum sum using this query. So this is the second query, which is again having a nested query which will get the same order date, order customer ID, and revenue, and from that I am getting the order date and maximum revenue. Now you have with this query you have order date, order customer ID, and sum of revenue for each order date and customer. This one have order date and maximum of revenue for each day. Now I can join these two on order date and the revenue, and then you will get the order date, order customer ID, and the revenue with the order date and order customer ID with maximum revenue along with the revenue itself. So if this is the join condition for these two queries, and the main query starts here and ends here. I am also ordering by order date here directly, and this is how you can implement the same logic to get the maximum the customers who have the maximum revenue for each day, or who have generated the maximum revenue for each day. You can run this query, copy and paste, hit enter. For in data dot collect, it is already sorted, so we don't need to do sort by key. Print of I and hit enter. You can see the details. The first one is order date, second one is the customer ID, the same one 3464, and the revenue is 182575. And the reason why it is repeating is that I am doing the self joining which is having three fields, three columns from the first subquery and two columns from the second subquery. Hence you can see it has redundant information here. It returned actually 5 values because 3 plus 2 is 5. And then to get the count, you can say data.count and hit enter. Here it will give little bit more because there are some duplicates, means there are multiple customers who are generating same maximum revenue on few days, and I think there are two or three records. So the result between the previous query and this query is little bit different. As this query we are actually getting all the customers with the with the highest revenue for each day, whereas in the previous query it will whereas in our previous Python based logic, it only returns the latest one. If you want to get the same results as this query, then you also have to do the same thing. First you have to get the total revenue. So this for each order date and customer, which is given by this one, and then you can get the maximum. Instead of returning order date and the two fields, or customer ID and maximum revenue, dump the customer ID and get only max revenue and the order date. Now this one have order date, customer ID and max revenue. If you dump after this one, this one will have order date, customer ID and revenue, and this one will have, after dumping customer ID, will have order date and max revenue. By joining order date, max revenue of this modified result set with this result set, you can get all the customer IDs with who generate the maximum revenue on each day. So it's pretty straightforward, it's not complicated. Probably it might be a good exercise for you to do that, either to get the customer details who is generating the maximum revenue, or all the customer IDs who is generating the maximum revenue for each day. Both are good exercises to continue from here, so that you make sure that you understand the joins and aggregations for the certification. That being said, before closing it off, if you have to write a complex SQL type of queries, if they provide access to Spark SQL, as they do here in Spark 1.2.1, I will recommend you to launch the Spark SQL. Like this. And then it will automatically launch the Spark SQL command line interface in Hive context, and you can write the Spark SQL queries directly here. And also, if you are very familiar with Hive, most of the queries in Hive will run in Spark SQL, but some cases it will not run. For example, in this case, to get the maximum revenue, to get the customer details with the maximum revenue, you can run this query, which is much simpler than this query, because it is not doing too many self joins. It only does one join between orders and order items, and there are no self joins. This is called as analytics functions or windowing functions. This query works well in Hive, but this query does not work in Spark SQL, even in Hive context, because Spark is not capable of parsing it properly and executing it with the appropriate logic. It will parse it, and then it will fail that it do not understand the query. So this one, if you run in Hive directly, it will give the same result. And other than that, if you want to develop the query based approach, first run the query in the Spark SQL, make sure your query works fine, and then once the query runs fine, then embed it into the Python based script using Hive context to get your results quicker at the time of certification. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you have any feedback, please use the comment section of the video. If you have any questions, please go to Stack Overflow and ask me questions with proper tags such as Apache Spark and Pyspark. And if you are interested in discussions, please join my group IT-versity Hadoop Certifications or IT-versity Apache Spark, so that we can discuss on relevant topics. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.